Okay, so page 8 of the C programming notes, and we just talked about function pointers. Now I'm going to talk about something a little simpler, which is the size of integers in C, or sized integer types. So C leaves a lot up to the compiler. One of the things that it leaves up to it is the size of integers. So C integer sizes are compiler dependent, and the rules in the C spec or specification are that chars, and we usually use a char to represent a character, but really it's just an 8-bit or greater integer, so it's at least 8 bits. If the compiler wanted to use 9-bit chars, I guess it could, but that's unlikely. Next is the short int. When you declare a short int, you can just declare it as a short. You don't have to write the int part, so I'll put that in brackets. That's got to be at least 16 bits. The int type, which is what we usually use, has to be at least 16 bits, and it will depend on your processor whether it's 16, 32, 64. Next up is the long int. Again, the int part is optional. That's got to be at least 32 bits, and then we've got the long int, which has to be at least 64 bits, and these can either be signed or unsigned. If you want it signed, you just leave the signed part off. If you want unsigned, then you have to explicitly preface the type with unsigned. So a char is no bigger than a short, which is going to be no bigger than an int, which is no bigger than a long, which is no bigger than a long. So those are the rules, and as a result of that, an int could use 16, 32, or 64 bits of storage, and it depends on your compiler and which processor you're working on. So usually an int is going to be the same as the word size for your processor. So what's the problem? And don't know if you can see it, but the problem is portability. So you might write the code once, and maybe it was a long time ago, you're writing an I/O driver and it's on a 16-bit processor, and your I/O device lives on, you upgrade to a new processor, and now you're running the code on a 32-bit processor. Behavior can change, so whereas a 16-bit int has a range of roughly plus or minus 32,000, 32-bit int has a range of plus or minus roughly 1 billion. So the problem is, let's get this color to make it stand out, lack of portability. So just as an aside, while I'm talking about the size, let's do this way. So the range of a signed 16-bit int is this -2 to the 15 to +2 to the 15 minus 1, which is, let's hope my memory serves right, -32,768 to +32,767. Likewise, the range for a signed 32-bit int is negative 2 to the 31 to positive 2 to the 31 minus 1. So that's roughly plus or minus 2 billion. And that has to do with the way signed integers are represented in C, so using 2's complement. Actually, 2's complement, or sorry, C is actually, the specification is agnostic about how you represent signed integers, but every processor I've ever seen works with 2's complement representation. And just for completeness, range of an unsigned, let's do a 16-bit int, is going to be from 0 to positive, what would you guess here? 2 to the 16 minus 1, which is 0 to positive 65, and I forget, 535 maybe. I'll double check that after. Okay, so that was just an aside. Let's go back to signed integers. So, not in the original C standard, but later, I think with C99, we got sized integer types. So size types are better, especially for embedded systems. The header file that they're included in is standardint.h, and it provides these types. int 8 underscore t, so that's 8 bits of storage. int 16 underscore t, int 32 underscore t, and int 64 underscore t. And then there's the unsigned variant. So unsigned uint 8t, uint 16t, uint 32t, and uint 64t. So these are signed, these are unsigned, and no matter what processor you compile and run your code on, you know the exact number of bits that are used to store that number, and that will give you predictable behavior between processors.